All right, we are on to the probability section. So we will be looking at probability of things. So, or the number of events such things can occur. So to determine the number of ways you can have something, you're going to use multiplication. For an example, a pizza house offers 4 different kinds of pizza and 3 different desserts. How many different 2-course meals could be ordered? So from our 4 pizzas, we could have, say, a pepperoni, a cheese, a meat lovers, and a vegetarian. And desserts, we have ice cream, chocolate cake, and pie. So I could have pepperoni and ice cream. I could have pepperoni and chocolate cake. I could have pepperoni and pie. Then I could have cheese pizza and ice cream. I could have cheese pizza and chocolate cake. And then I could have cheese pizza and pie. What about the meat lovers pizza and ice cream? Or the meat lovers and chocolate cake and meat lovers and pie? Or you could have vegetarian and ice cream. You could have vegetarian and chocolate cake, and you could have vegetarian and pie. So how many did I have here? If I count them up, I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you could do it that way. The problem is that we're going to get some really, really big numbers, and it just won't. It'll be really hard to be able to list out every single possibility. So you need to know that you can take the 4 and multiply it by the 3 and get the 12. So if you had like a starter 4 pizzas and dessert, you would then be able, let's say we had 7 starters. Okay, I would be able to do, along with the 4 pizzas and 3 desserts, I would be able to do 7 times 4 times 3, which would then give me 84, I think, possible outcomes. And I wouldn't want to list 84 options. That just is way, way too much. So just remember that if they're asking for the number of possible number of items, you can multiply. All right, you might get something like this. Suppose we describe the weather as either sunny or cloudy. Using the letters S and C for all possible outcomes, determine the 2 consecutive days. So again, we're going to list them out. So day 1 could be sunny and day 2 could be sunny. You could also have day 1 as sunny, day 2 as cloudy. Or you could have delete. Or you could have day 1 be cloudy and day 2 be sunny, or day 1 be cloudy and day 2 be cloudy. Okay. So if we are interested in the number of S days, what are the possible events of 2 consecutive days? So they want to know how many days it's sunny. Well, how many days is it sunny twice? Once. But then I have 2 that we have 1. Let's see. Sorry, that was wrong. Okay, so I do have sunny twice. So I have 2 days that it is sunny. But these 2, I have it sunny once. So I have a possible outcome of 1 day of sunny. And cloudy means I have 0 days. So my possible events for 2 consecutive days would be 0, 1, and 2, which is different than the probability. So note that this is asking what are the possible events versus the probability. Now let's go into probability. The probability of event A occurring is the number of ways A can occur over the total number of possible outcomes. So let's use a theoretical method to determine the probability of the following outcome and event. State any assumptions made when tossing 2 coins and getting either 1 head or 2 heads. Okay? So when I toss a coin, the first time I toss a coin, I could either get heads or tails. From that heads, I could either get heads or tails. Again, heads or tails. So I could have heads, 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 tails, tails, heads, or tail, tail. Tossing 2 coins and either getting 1 head. So let's look. Where do I get 1 head? I get 1 head when I go head, tail, so that's 1, or tail, head, that's 2 possibilities of getting 1 head, or 2 heads, which is head, head. So I would have 2 plus 1 all over. How many possibilities do I have? And I can count this row right here, 1, 2, 3, 4 out of 4. So I would have the possibility of 3/4 of this, either getting 1 head or 2 heads. What is the probability that a randomly selected person has a birthday in December? Okay. I every year I go with the assumption that we are assuming that a person is most likely to be born in December as any other month, and so I come up with the answer 1/12 because there's 12 months in a year, and that is wrong. That is not what the computer is looking at. They're looking at actual days. So how many days are in December? Well, there's 31 days in December, and how many days are there in a year? 365. Okay, if they picked a month that had 30 days in it, you would then have to reduce. All right, moving on. Okay, you toss a coin 300 times and you get 48 tails. Determine the relative frequency of the probability. So the relative frequency is the number of times we had the tails divided by the total number of times we flipped the coin. So what is it? 48 divided by 30, or 300, is 0.16. Okay? When we throw a coin, what do determine the expected frequency of the event? So if I'm going to throw a normal coin, what do I expect? How many times do I expect? How often, or what's the probability of getting tails? Well, I expect it to happen 1 out of 2 times, which is 0.5. Okay. Now, do you have a reason to suspect that the coin is unfair? And explain. And my answer would be, yes, it is unfair. And that is because I would expect my frequency to be closer to 0.5. It will probably not be exactly 0.5, but I do expect it to be closer to 0.5. Expect it to be closer to 0.5. All right, let's look at this one. Determine the probability of the given opposite event. What is the probability that a 45% free throw or shooter will miss her next throw? So 45% of the time, if I asked you what's the chances of her making the next throw, you would tell me 45. But I don't want the 45. I want her missing her next free throw. So that would be 1 minus 0.45, or how about 100% minus 45%, giving 55%. So between either making it or missing it, it should always add up to 100%. So for her not to make it,